Hello there. For this final project of INSE 6190, we are doing the project 2, Security of WLAN. Since this project requires 4 attacks to be done, and we are a group of 4 teammates who have chosen each attack to be performed for the video, even though we all have done all the 4 types of attack and more ourselves to learn how this works. But for the video presentation, we are only presenting one each. For the part 1 de-authentication attack, we have selected a targeted access point chosen after the reconnaissance operation. And once that has been done, we send the de-authentication packets so the clients connected to it can be disassociated with it. In part 2, we did the password recovery from those disconnected clients, connecting again with the targeted access point and perform the handshake. We captured the password during that handshake process. When we received the password in part 3, we added our own malicious client into the network. This gave us opportunities to sniff the network traffic, analyzing the clients, and then to do the DNS spoofing through the man-in-the-middle attack. Since we have performed everything within a third-party network provided by a targeted access point, in part 4, we created our own fake access point. So we can create our own network. This rogue access point provides better vulnerabilities exploitation setup than doing it on a third-party network. Let me hand over the presentation to my teammate for executing the part 1 of the project.
Thank you, Neil, for giving me the floor. Guys, now I will perform the de-authentication attack, for which I will use TP-Link adapter. And as you can see, my adapter is in monitoring mode now. Now I will discover my target using arrow dump command. I got my target. This is my target, and this is the BSS ID of my target, and it's running on channel 2. Now I will identify the associated clients with this, and the command will be arrow dump ng -- channel number and the BSS ID. So I will put the BSS ID first and correct the channel number, which is 2, so that I can identify all the connected stations. Here you can see there is one station connected with my agent access point. Now I will perform the de-authentication attack. So arrow replay ng de-authentication attack, and the SSID is 82A5. I have to put the SSID of the agent and the SSID of the station, and the station SSID is same 6A88. Now the de-authentication attack, here I will send 50 packets 50 seconds to perform the de-authentication attack. Here you can see the authentication attack is going on, and yeah, I got the handshake. So that means the device, the station disconnected from the station BSS ID and again connected with the BSS ID, and I got the handshake. That's how we perform the de-authentication attack. Now I will hand over this platform to our next teammate, and he will demonstrate how to perform the password recovery attack.
Thank you, Sojit. Now I will perform the second attack named password recovery attack, in which previously he just performed the de-auth attack and captured all the handshake. So now I will find out the keys from the captured handshake traffic. So using this aircrack command, here I will write the file name, and using the rocu file, we will try to find out the actual password. Now we found the password. It is the password. So this is the attack. It is a password recovery. And now I will pass the floor to my teammate Anand. He will explain the third part of the project.
Thank you, Tejas, for passing the flow for the project. So let's get started with the third part of the project. So till now we have seen that we can just search the available networks from the connected wireless Wi-Fi adapter, and we can just capture all the available networks, and we can just select our victim and send the de-authentication packets, capture the WPA handshake, and then just crack the passwords. So after we have the access of the internet, we will just enter the internet. So for this particular case, I have used this particular Wi-Fi network using my my external Wi-Fi adapter. So as we can see that this is my external Wi-Fi adapter, and this is the IP assigned to my my Wi-Fi adapter. Okay, so let's get started with the tool. So the tool which we would be using in this particular example would be the BetterCap tool. So we have the BetterCap tool in our apt repositories. So we can just get it installed by the sudo apt install BetterCap, and we can just get started with the BetterCap tool. And we can just write sudo BetterCap and just give the interface as WLAN 0, which is the wireless interface for our adapter. So let's just get started, and let's start with the help command. So we have these many modules available for this particular tool. For this particular example, we would be using the net.probe for listing all the devices, the available clients connected to the wireless router. So net.recon would be automatically turned on as soon as we turn the net.probe on, which is the requirement for this particular tool. And sniffing would be the sniffing the traffic for any target which we would be setting up right now. So we would be starting with the net.probe service and turning it on. So we can see that the net.recon also got started. So we can see, yeah, so both the services are now running, and now we can just start spoofing the data. So for that we just need to set the arp.spoof.fullduplex as true, and just after that set the arp.spoof.targets. So here we can see that this device was connected, so we would be taking this endpoint and would be taking it as the victim. So we have done that, so we will be just doing the arp.spoof on. Okay, so so our ARP spoofer is now started, so we can just come here, launch the terminal, and do the IP config. We can see that this is our victim machine's IP, which is same as what we have given here. So we will just start with a simple website, which is certifiedhacker.com. So now we can see that our website, the legitimate website, is working for now. Okay, so we will be going back, and so let's just do the net.sniff on. Okay, so now every traffic would be, yeah, so every traffic is now flowing through our sniffer, and we can sniff all the traffic right now. Okay, so let's start with the DNS spoof. So DNS spoof first we would be configuring the basic DNS spoofing, all the requirements which we need to set for this particular tool. So for that we would be just doing the set DNS.spoof .all as true, so that every traffic is being spoofed, and after that we will just set the DNS.spoof domains to be the certifiedhacker.com, and the second one could be anything.certifiedhacker.com. Okay, so we will just DNS.spoof, we'll just turn it on, and now we can see that the DNS would be spoofed and it would be sent to this particular IP. So if we for now just copy this IP, go to here, see, so this is our web page which should be which the victim should be redirected to. Okay, so that's on. Let's go here, close this, open another terminal, see that certifiedhacker.com. So now we can see that it is the same web page which I just showed you here, and also you can see that okay, so DNS is being spoofed, and the sending spoof DNS reply from this particular the DNS, and it is being directed to our hosted Apache server. So like just as a requirement, we just started the Apache server, which was the requirement for this. So for that we use the sudo service apache to start, so that's just a simple command. So we can just see the status right now that our Apache 2 service is running right now. So so here we just complete the DNS spoofing attack, and here we can see that the victim is being spoofed for the exact same website which I just showed you before. So that was the flow. So now I request Neeraj to perform the last attack, which is about creating a fake access point, which is a rogue access point through which we can do a lot of stuff.
Hello there. So far in part 1, 2, and 3, we identified the targeted access point and did the de-authentication attack. And after the de-authentication, we performed a password recovery through the handshaking of those de-authenticated clients, because once they are reconnecting with the access point, they are kind of handshaking, and in between that we can get the password out of it. In the part 3, when we knew the password of that access point, we introduced our own malicious device into the network, and after that we did all kind of analysis on that particular network. We were sniffing the data, we were watching the traffic through man-in-the-middle attack, and we did some domain name spoofing in that as well. Now, as that was only inside a particular network, we are trying to perform a, we are trying to create our own access point. This way, it will give us opportunity to exploit much more vulnerabilities, which we were not able to do in a closed network. Here, we are creating our own fake access point, which will not have any kind of password because it is a rogue access point. It will allow any kind of client to attach with it. For this, we are using a well-known script from Oblique. It is a create AP script. It is very useful to create a nated or bridged Wi-Fi access point. Why nated and bridged access point? Because we are bridging the internet from our reception device to the rogue access point. This also provides the client isolation so that no two devices within the same network will be able to talk to each other. This also includes a different kind of encryptions like WPA, WPA2. It also provides no encryption, which is what we are going to do because we don't want any kind of security, so any user can connect it with our rogue access point. To run this script, we need some prerequisites, and that includes few of the algorithm-based libraries. We are using HavisD because HavisD is a user space daemon. It generates an unpredictable stream of random numbers harvested from the indirect effects on the hardware events. It actually caches branch predictors, memory translations that is happening within any kernel using the Havage algorithm, which is hardware volatile entropy gathering and expansion algorithm. This after that we have host APD. That is required to create any kind of access point in the host, and that also act as a authentication server. So that is why it is most required here. Once these has been installed, it will allow us to create an access point with a very simple command, which is sudo create underscore access point. We are creating on WLAN 0 because that is where my wireless adapter has been put. We are taking internet from Ethernet 0, which is the native Wi-Fi NIC card on my device, and we can then name any kind of access point ID here. We are naming the SSID, which can be, let's say, access underscore point. It should be good. Once I run it, we'll see the AP enabled. That means the access point has been enabled. Now to check it on our live device, I have added my phone here, and with this we should be able to check whether that access point is accessible right now or not. The access point name was access point, so this is available. It don't have any security because we did not set any security. Let me connect it with that. I have this access point connected here, and since the connection, you can see that we have the MAC ID showing up here. It is associated here on this protocol, and now we can try to check if the internet is working or not. So our device is running live internet on this access point. It solves our motive. In conclusion, I would say that from this project we learned various things. We did the reconnaissance, we found out our targeted victim. After that, we also recovered the password from the already available access points within the vicinity, and once that has been done, our malicious actor was a part of that network where it did the snooping and sniffing within that network in limited quantity, but it did very well. And after that, we created our own access point. Here we can analyze the traffic, we can do the phishing attacks, we can even create an evil twin of this access point. So this gives us a bigger window, more opportunities to exploit the vulnerabilities with the clients and the snap data. So that was all, and we learned a lot. Thank you very much.